So here in part 2 of the video, I'm sort of forcing you to stick with that part 1 first, to go back in there and go into it until you can find the clue. I decided to go with that and watch part 1 over and over again till you see what I'm driving at. I've already given it to you numerous times. Again, do your bullet points to determine this. If you want the answer, I'm going to give it to you now. If you don't want the answer, do not watch the rest of this video. All right, here's beam 101. From here to here, this is also beam 101. See it? BM 101, see it's written right here? Oh, wait a minute, it's not written right there. Okay, so let's think about intent. So the intent of beam 101 here was to help distribute and carry the load of the roof load. This roof load here, down this column here and here. So this is why we would see beam 101 here and not a beam here. All right, so you see a beam here, but not here. So you would, intent-wise. And the span is so great that they had to do another, you know, so you don't have to make a large beam, super large beam. They did another beam 101 there, and then they went this direction with the beam and a little transfer beam here. I believe there's this little thing here. Looks like that. Shit. Looks like this. And this is this. This little section here is here. Okay? And then they mounted here. This is the corridor, the hallway here. And then you would turn and go this way. All right, let's clean that up a bit. So that is missing. That is missing at this point. And the failure, we don't see that in the images that I presented to you. So now we have intent of what these beams are up here. But why no beam here? I think this is part of the flaw and non-flaw and part of the failure. Is that they ran the, let's see if I get this right, yep. So this is the face of the building. It's a 16 by 16. But what do you notice? If that's a 16 by 16, it's sitting on approximately 8 inches. 8 inches of the floor there sitting on, is on a column there. Also, the beam, let's clean this up now. This beam 101 is also sitting on half of the column, as indicated in real life imagery from using Google Earth. Right there, you can see the rest of the column sticking out. Now some parging, concrete parging, mortar, plaster, however you like to call it, has been put on here to make it blend in a bit. But you can clearly see it sticks out. So we've got about 8 inches of wall support and this roof decking supporting on an 8-inch column. 8 inches of that column. I believe that when the structure went down, this little section here was a section that went down because of the engagement here. Now, I also have two beliefs. So one of them is that the floor down here, which I think is a 10th, failed. But using the roof line is my other point of failure, because I have to speculate debunk myself, and I can get there 2 ways. I can get there from a lower floor, not very deep down. We're only talking about the 10th floor here. Let's see if I get that right. Let's see, 12th, 11th or 10th floor. I keep changing in my mind here. It's pretty disturbing, irritating, because this is the 13th floor penthouse. 12th floor is here. I believe the 13th floor penthouse went down onto the, I know it goes down at some point onto this floor. And these two, the penthouse floor and the 12th floor, so 13th and 12th floor, reacted together to hit on the 11th floor. The 11th floor could have been our buckling floor. Looking at shake tables failures, concrete shake table failures, Often a mid-floor can fail. A mid-floor not necessarily meaning mid, like you've got 13 floors, and so we pick the 6.5 floor. No, it's just a mid-floor, meaning a floor between. It could be the 4th floor of a 12-floor building, for example. It's just depending on how they shake it, where it picks its poison. All right, and remember, the shake tables are often using concrete that's cured for 28 days. This is a 40-year-old structure with plenty of beat down on it. All right, a lot of beat down on it. So it's not going to behave the same as a shake table. So you can't really extrapolate too much from the shake table besides that it can fail on any floor during an earthquake, during a shake table failure. Any floor. In this case, we have multiple repairs that have been done, including the roof repairs, multiple places, and replacements, even in the 10-year-old roof, I believe. So it had some water issues going in there. So there's a lot to extrapolate from. Going back to this 8-inch, remember there's a beam over there, there's a beam here, there's a beam here. This beam comes back to there. There's a beam here and a beam here. And then there's a beam back over to there. There's also a cantilever beams off of this elevator, and then this is a column, and then another beam across the top of the top there, one at the bottom also. So as I rotate them to clean this up, rotate this around, there is the beam that goes across here. As I tilt up a bit, rotate, there's a very small beam that goes across there in a cantilever fashion that comes across here, resting on top of this one here, this beam that goes across. Let's go back to the image. So from here, we've got just 8 inches of cover there. How is it engaged? How is it there? It doesn't detail it. It doesn't detail the critical shear zone, how they engaged in there. But you can extrapolate that it's only going to be something like that. Now keep in mind, there is a detail in this drawing that talks about put two number 4s underneath each block wall. So this is a block wall here. So there's 2 number 4s going from, since it's a block wall, going from there to there. But they don't talk about the top steel that would be needed as you come out of that floor, because if you just put it at the bottom, well, not all of the load is there. So let me do this for you. Here's a support. Let me clean this up. It should be treated like a beam. Those 2 number the steel. Here's a column, and we're looking at it from the let's see, you call it a side view, and it's just put it at the bottom. So there are 2 number 4s at the bottom. Are they on top of each other? Now looking top view down like a bird's eye, and here are the columns, or were their intent like that? Space them out a bit. Okay, so I don't really care, but it's only 2 number 4s. Looking at it like this, and then they put the block wall on top. You put your block wall on top of here. All right, let me just do a couple of block walls here. All right. In the mid-span is where the deflection happens, but it creates a different strain being at the bottom. Here it is here like this. Then at the top, there should be some top steel there also. And I believe in cant strips, so it's like this to help with shear fracturing. Because when the stress is there, this wants to deflect. And upon deflecting, this is what this cant strip does. It keeps those 2 sections locked in. Cant strips are not used in the United States. No one's doing crank bars in the United States. Crank bars. Crank. Not crank like as in crank, but crank. You can look this stuff up, all right? This really helps with that issue. They do it everywhere but the United States. They're not doing crank bars. Engineers in the United States are so full of themselves, they're not paying attention to real world reactions. They just follow ACI like it's God talking. ACI is not really down with the crank strips. All right, so crank bars. So over here now, we have the engagement. It's only 8 inches. So we get the building rattling. Now, let's say this breaks free, the little 8 inches, because it's not much. Well, it's the load. Once this breaks free here, the load now, this whole section here, including the cantilever, the porch, it now has to be taken on by the 3 points here. This point, and this point. Of course, it cannot do that. And so it punches around these guys, theoretically, punches around here over to here. It separates because this part of the building we see still in place. So it separates. It goes back to here, here, and here. And now, let me get rid of that one. It separates. Oh, let me clean this up a bit. It separates around a punching down, and that's when we see the black roof. We see black roof presented to us here. Oh, but we also see black roof at one point presented here. But number one, we first see this zone here of black roofing. And then number two, we see the top part of this walkway roofing. So this roof goes down first. This is all punch sheared, but at one point, let me clean this up now. At one point, we need to get this to rotate. How do we get this to rotate? You can pause again and catch your own clues, but the crank, what's happening is this decking is tied in to this beam, the beam 101. It acts like a lever. When it goes down, it's able to rotate. This lever, 101, is also tied into these beams here, and the beam going across here. It's able to act like a lever, the whole pad is, and rotate this section. Because of the beam interaction with this pad here, the roof pad, all right, it's able to rotate that beam. Upon rotating that beam, it's also able to rotate these beams here, torquing them. And that's why we're able to see the failure rotate in the video. Let's see if I can find the video again. I might have to go to my own video. I'll try to keep this for another 3 minutes. So let's tie in back into this. So remember, this is like an upside down beam also. The turned up beam, well, here's the beam. The beam is the top of the cantilever wall system that's bonded with the floor. Remember, there's a floor, and they have reinforcement about every 4 feet. So when that floor rotates down, these top of the parapet wall also acts like a lever, able to force the rotation down, along with there's a beam back here. But this section here does not have a beam underneath of it. It has a beam up. The beam would be extrapolated to be up top, and also the beam would be part of this cantilever action. The cantilever porch going over top of this lower porch. It's also rigid at the top there. Remember the design of it. All right, that continues over here. So you're basically coming away with a double and sometimes triple system here. So let's clean this up. Let's go to red. So first you have whoa. Let's see if I can actually literally just tie it in here for you a bit. I can't zoom in any bigger than that, so let's do this. So here's the top of the wall, the top of the parapet. I'm going to grab a section of it. That's supposed to be solid poured. And then you got rebar tied down into the deck, into this deck. And over here, though, you have the solid poured tied down into the deck, which also is a beam down there. Beam 100, whatever it may be, and the other beam coming this direction, beam 101 maybe it's called. This all acts like a reinforced cantilever action that's able to later to rotate, to torque this whole back wall, to torque this section to torque this section in the video we see. So first we see this torque, and then this is engulfed, and we see that torque. At some point it breaks there, and we see it grab at it twice. Very interesting. I want you to, and I'll post a video if I get permission from the group, because I made it private for them. But this is very interesting. This section here is actually going to be over here. So even though we see the torque, there's some point where the rotation's back towards the front of the structure. This front being that this is the front, this direction, which is north. So in this video, this is this section I'm talking about. And we see some debris there on top of it. It's dusting my roof up. It's a clean line there. I mean, you could, if you want to, you could say that it only went over to the column over to KL, probably L, but I don't believe that. I believe it made it all the way to N, KLM, N. Oh, it would be M. This would be M. And then, but I believe it made it all the way over to N because we see the destruction of the building has already taken place. And I think we're just looking at, a cloud of concrete dust debris. You can see the torque taking place here now on the back wall. Well, you can see how it all engaged and the torque taking place. Of course, the video is too small to see that there's probably some fractures inside that black roof line. Let me go back. So there's that torque taking place in that corridor. You see the title of the video. You can pause it and get the title and go back to this video. I'll post it on the other channel also. But you see, first we see in this part of it, it's 1835. You see that's the roof going first, not the corridor. All right, there's the corridor. There's that roof section. It goes first. This is first, and then the beams act as an arm along with the parapet wall, pry bar, prying action, an arm to rotate this next section. And again, 1835 in the video, and I'm only going to see if I can go, if I can bounce it just a bit. Might have gone too, okay, there we are. Now you see that it's starting to rotate the corridor, and the corridor is there. And then you can see that's part of the corridor, how it's rotated. And at one point, it's rotated and the floors below have failed, so it can't even, there's no longer support underneath that corridor. So it tells you there was some support underneath that corridor at one point. Now you can see the corridor roof drop down, and so that means we're losing floors. All right, we're losing supports. But there is still a tie into the existing shear wall, the existing structure. As you can see, the flat part of the corridor. The wall going upwards, still the roof upwards, in a visual. So this part over here is still, now it's flapped down, and it looks like that. Right there. So flapped over, and so it's like that. And then now we're getting progressive floors below failing, and so now it just wants to drop down and rip it off, tear it down. This corridor rotates away, and that's why we're able to get that ductwork in such great shape. So again, this is part 2 of the video. I have more details to give you on this, but I'll just keep it to part 2, and this is why this title's here. I'm going to put it on the other channel also. I get out of YouTube jail on Saturday or Sunday. I don't know which day it is, and I'll load this one up there. And then I have to wait, per my insider talking to me, I have to wait quite a few days. Then I'll post this video that you're seeing. Oh, actually, I'll post number 1, part 1 here on there, and then part 2 afterwards. It might take a week and a half to post them. Because I found out part of my shadow banning is they figured out is that reason why they can keep telling me no shadow banning. The guy gave me the code, if you will, Had to read between the lines. It was pretty simple to read between his lines. Spam. They put me on as spam. And so with that said, he actually told me I have to change the name of the titles. It's a damn shame that I have to do that, because now who's going to find the content? So I won't do it. I won't change the title, and yes, it'll only get 400 or 500 hits, and that's it. If I change the title to something current, I'm in the clear. You know, if I want to talk about, Biden falling down the escalator steps and then post this, then yeah, I'll get jacked up in the views. But that's not what I'm about, am I? Take care, guys. Love you. Bye. Please engage down the bottom. Comment. Give me some comments. Thumbs up. Comments. Engagement really counts, is what he also told me. I need people to engage. I know YouTube blocks a lot of you. Try it anyway. I do see a lot of block comments. I approve most of them. Some of them people are just so far off that I don't need that craziness when they tell me about the earthquake happening that did this. All right, so or they're looking for the hard drive of Epstein in the building. Of course, we know they found the hard drive there. I'm just teasing. Bye.